and power. Here we are going to discuss the topic name is work, energy and power. Now about work. So what is mean by work? What is mean by work? Work means whenever we apply the force, F force on the block, so then the block undergoes to displacement. When we apply the force F, so there is a body undergoes to displacement. Then the force is said to be a work is done. Now I am giving the definition. A work is done if the force is acting on this body, then it displaces through a displacement gas. That is called a work. Here F is the force which is acting on this block. This F component is F cos theta and F sin theta. F is resolved into two components, F cos theta and F sin theta. The displacement of the particle is or body is S. So what is the work done? Work done is equal to force component into displacement. Force component to displacement. Or we can also write Fs cos theta. So this is the equation refers to the work equation. Now I am going to give the units of work. Units of work. Here units of work we can measure in CGS units. CGS units ergs or dyne centimeter. MKS units joule or Newton meter. Work is a scalar. It is a scalar. It is a scalar quantity. Scalar quantity. So we have another units of work. Another units. What are another units? So these another units are electron volt. Electron volt. So electron volt EV. 1 electron volt is equal to 1.6 into 10 to the power of minus 19 volts. And we can also measure kilowatt. Kilowatt. So 1 kilowatt is equal to 3.6 into 10 to the power of 6 joule. That is watt. So these are the units of work. Definition of work. Now I am going to give the nature of work. Nature of work. Work can be classified into three types. One is positive work. Another one is negative work. Third one is zero work. Zero work. So how can you understand the positive work and negative? The next zero work. Here positive work. Positive work. What is meant by positive work? For example, a block of mass m is lifted up at a height h. So there is the displacement of the block is h from the ground. We lifted up. So what is the work done is positive work. So according to there is a Fs cos theta. Here the angle between them F and H, both are parallel, so angle between them is 0. Therefore W is equal to Fs cos 0 1. So work done is positive. Next, negative work. Work done by the gravitational force. So weight of the block is acts downward. applied force is upward. So there is an angle between them is 180 degrees. So we can write W is equal to Fs cos 180. Here cos 180 is equal to minus 1. Therefore work done is negative. So this is the negative work done. Next, third one, 0 work. A block is moving on the rough horizontal surface. This is the applied force. Displacement of the block, yes. Here normal reaction is upward. Weight of the block is downward. So if you take the normal reaction to the displacement, perpendicular. In the similar way, applied force to the weight of the block is perpendicular. So work done is 0. So we have three types of nature of work: positive work, negative work, 0 work. When you lift the object, there is a work done is positive. When you lift the object against the gravity, there is a work done is negative. A block is moving horizontally on a rough horizontal surface, so the normal reaction is acting upward, weight is acting downward, normal reaction is perpendicular with the displacement, so work done is 0. Even applied force here perpendicular to the weight or displacement of the block is perpendicular to the weight, so work done is 0. So these are the three types of nature of work. Next I am going to give the graphical representation work done by the variable force. Work done by the variable force and work done by the constant force. Work done by the constant force. Work done by the constant force. Let us consider a block of mass m is present on the horizontal floor. We apply the force F constantly. The displacement of the block is constant. So work done by the constant force is F dot S. Next, work done by the variable force. So how can you understand the work done by the variable force? Let us consider an infinitesimal point A and B. There is a displacement of the particle is ds when we apply the force F. So which makes some angle theta. There is a small work done. The small work done dW is equal to F into ds. The above equation is integrating within the infinitesimal distance. So F dot ds. Integral dW is equal to integral F dot ds. Integral dW is W. So integral F dot ds. So this equation refers to the work done by the variable force. We can also write the work done by the variable force in terms of components, rectangular components. Here along x-axis F components, along x-axis Fx I cap, along y-axis Fj, Fy j cap, along z direction Fz k cap, on the displacement along x-axis dxi cap, along y-axis dyj cap, along z-axis dz cap. So here we can write W is equal to overall the A to B, integral A to B F dot ds. Here we can write A to B. This only can be written as A to B, integral A to B Fx dx, integral A to B Fy dy, integral A to B Fz dz. So this equation refers to the work done by the variable force. So we have discussed work done by the variable force. Next I am going to give the graphical representation of a work. Graphical representation. Graphical representation of a work. So we can represent the work done in terms of graph. One is, if you take the displacement values are along x-axis and force values are taken as along y-axis, then you will get a graph which is the area of OPQR. This area of the OPQ gives the work done. So W is equal to area of OPQR gives the work done. So above the x-axis, so it gives positive work. So it gives positive work. If the graph is represented below the x-axis, so it gives a negative work done. Area of the OPQR. Here W is equal to area of OPQR. So that is the work done which is negative work below the x-axis. These are the some graphical representation. Next we have some more graphical representation.